Good day, guys. So continuing from our exercise number 1, now we're on exercise 2. So on exercise 2, we're designing a run-on brake for a drive shaft, right? So now the training aims of the exercise is be familiar. So now we're being familiar with the function of a three-way normal open valve, right? And then we should be able to recognize and sketch various types of actuation and be able to set up and explain direct actuation, right? So direct actuation. So before we start, I want to talk about direct actuation. So you'll please try and reference the previous exercise that we're in, because I might have neglected to explain what direct actuation is. So direct actuation is a method in pneumatic systems that is used to directly control the movement of mechanical components such as cylinders, or yes, like cylinders, let's say cylinders in this case, or they're saying valves, without the need of an intermediate component like levers or linkages, right? So now you sort of like we're using in this case, if we go back to this exercise, so this is an example of direct actuation, because for us to supply air into the cylinder, we're directly using the push button without creating any components or having any components to that is between the push button and the annual actuator, right? So that's an example of direct actuation. So in direct actuation, the control valve the control valve flow the speed of compressed air directly into the pneumatic cylinder. So now the air is flowing directly into the pneumatic cylinder, doesn't flow through any other components before it goes to the pneumatic cylinder, right? So when the valve opens, the air flows into one side of the cylinder, causing the air to move in one direction, right? Causing the cylinder to extend. And when the valve closes, the air escapes from the side and then flows into the other side, causing the piston to retract, right? So basically, now you should be getting the idea of direct actuation. So now moving on to our exercise number 2, right? So now a three-way valve, it's similar to the three-way valve that's normally open, similar to a three-way. The functioning, I want to say the functioning. So it's basically the same component, but now in this case, a normal open, it's always open, which means it's always gonna allow air to flow through to the output up until a point where you press it, right? When you press it, that's when it cuts the supply of air going to the actuator or the cylinder, right? So now the description of the problem, they're saying an older engine plant has been retrofitted with a brake, right? So the brake is designed to reduce the length of time for which the drive shaft runs on when the engine comes to a stop after the clutch is disengaged, right? So the brake force is generated by the spring return in the cylinder, right? So as I said in the previous exercise when explaining cylinders, so the keywords will be in the description of the problem, or they will also be in the description of the process, right? So here, like from you hearing this word spring return, right? As I mentioned in the last exercise, we have in the context of what we are doing now, we'll only be focusing on the single acting cylinder and the double acting cylinder. And between the two of them, the only cylinder that is spring loaded, right? It's the single acting cylinder, right? So now, like if you are reading a statement and then you hear spring return, right? You should automatically know that like now the cylinder that I'm supposed to use, it's supposed to be a single acting cylinder, right? Okay, so now we're gonna move on to our description of the process, right? So now they are saying when the push button actuator is pressed, right, the piston rod on the cylinder retracts due to the force of the spring return, right? So now they are saying so now look at statement number 1. So now they are saying when the push button actuator is pressed, the piston rod retracts due to the force of the spring return. So now you should know that now your cylinder at its initial point in this circuit, it's supposed to be at an advanced position, and then when you press the push button, it's supposed to now retract, right? So now they're saying the push button is held down for as long as it's held down for as long as the drive shaft needs to be braked, right? And then the push button is released and the piston rod advances to release the brake, right? So now you'll see that now we also need to hold down the push button for the cylinder to remain retracted, right? So now you can also determine that the button you're not using, it's not latched. And then now going back to here, since now we already determined that the cylinder should be at its null position, it needs to be at an advanced position. So now we need to determine the type of 3-2-way push button that we need to. So now, deciding between the 3-2-way and the normally open and normally closed, right? As I said, in normally open, it's always allowing air to flow through. So it's like a tap when it's open. So when you open a tap, it always allows air to flow through, right? So now we need to make sure that our cylinder is in an advanced position and then when we press that push button, that's when our cylinder will retract. So now I can cement that now I'll be using a normally open 3-2, which will allow air to flow through, making the cylinder be advanced at its initial position, and then at the time where I press the 3-2, that's when the push button retracts, right? So now if we simulate our circuit, now you can see our initial position of the cylinder, it's at an advanced position, right? And then at a point where we press the normally open 3-2-way valve, that's when the cylinder retracts, and if I hold it down, it will stay retracted up until I release it, right? So that's our exercise number 2, right? So now moving on to exercise number 3. So in exercise number 3, we are clamping boards on a saw machine. So now we are using a cylinder to clamp boards, like this image is demonstrating. So now we are applying force on a wood plank to make sure that it stays secured while a saw is cutting it, right? So we are clamping boards on a saw machine, right? So now we're designing a pneumatic system that will help us with that process, right? So now in this exercise, you should be able to recognize the various types of actuations used for directional control valves, set up direct actuation, and then also be able to analyze and evaluate control systems, right? So now this is an image of the different types of directional control valves that can be used, right? So now you should go through this and also do your research, right? So now in the description of the problem, they're telling us that a circular saw is used to cut the boards to length, right? They're inserted onto the machine by hand, and then the sewing process itself is controlled by a dedicated console, connected by a dedicated console. To this end, the boards are clamped on a saw table for the test build. The control system will be set up with only one cylinder, right? With one cylinder, right? So now we move on to our description of the problem. So now they are saying a board is placed on the saw table by hand, right? And then when the switch is pressed, the cylinder piston advances to hold the board in place, and then the cylinder remains in this position when the switch is released. So now if you look at these two systems, they're telling us that they press the push button, and then even after they release, they don't hold it down or anything. They just press it once and then they release it. The cylinder will remain advanced, right? And then on statement number 4, they're saying the cylinder, when the switch is reset, which means now when they press it again, the piston rod will retract, or the cylinder will retract to the back end position, right? And then it will remain there up until the switch is pressed again, right? So now from this, you should be able to tell now that we are dealing with a different type of push button, right? So now, going back to our FLUIDSIM, right? So now, the three ways that we've been using, they are not latched, right? So now I'm going to introduce a new button, which is called a three-way valve, a three-way selector switch, right? So now, if you see this three-way valve, it's a normally open three-way selector switch, right? So a selector switch, when I press the push button, it's gonna stay there, right? Because a selector switch, it's normally closed, but the main point of a selector switch is that it's latched. So I only have to press it once, and then it allows air to flow through. And then when I press it again or release it, it cuts the supply of air without me like having to hold it down, right? So I only need to press it down once, right? So that's how a selector switch is different from this type of three-way valve, right? So now I connect it to my circuit, right, and then I press play, right? So now after I press play, I only have to press it once, it advances without me having to hold it down, right? The cylinder would remain advanced, or the piston rod, and then up until a point where I press it again, that's when it will release that's when it will cause the cylinder to retract, right, by cutting the supply of air, right? So now, moving on to exercise number 4, right? So now in our exercise number 4, let me try and open it. So in exercise number 4, we are designing a pneumatic system that is used for loading packages, right? So in this exercise, after completing it, we should be familiar with the functioning of a double acting cylinder, right? And we should also be familiar with the setup and functioning of a three-way valve, right? So this is a double acting cylinder. So a double acting cylinder is different from a single acting cylinder, in a sense that a double acting cylinder has a supply hole or a supply pipe and an exhaust pipe. So now the supply pipe, it's located at the back side, so at the end side. So like now it supplies air into the cylinder, which causes it to advance, right? And then the exhaust hole, it releases the air, or it takes the air back into the system, allowing the cylinder to retract, right? So they're saying here the double acting cylinder has a higher air consumption than a single acting cylinder due to the different surface areas of the piston on the piston rod sides. There are different effective forces at the same pressure, right? So now here they're explaining, like when a cylinder, like 4-stroke, when a cylinder advances, what happens to the workings of the double acting cylinder and when it retracts, right? So here they're saying the compressed air, so during when it's advancing or during its 4-stroke, right, they're saying the compressed air flows through the piston chamber supply port or supply hole, right, into the cylinder, and then pressure is built up into the chamber, and the force is applied to the surface of the piston as a result. When this force exceeds the static friction, the piston advances as a result, and so does the piston rod, right? And then the air in the piston escapes through the port on the So they're saying the air in the piston chamber escapes through the port on the piston rod side, right? So now they're saying this procedure, the full operating pressure, saying the full operating pressure is not reached until the piston is fully advanced, right? So now this statement basically means that the steam will continue to supply air into the cylinder up until the cylinder is fully advanced, which now when the cylinder is fully advanced, it indicates that the chamber of the cylinder has already been filled with air, right? So there's no more air that can go. That's when it stops supplying air into the circuit, right? And then during the return stroke, or when the cylinder retracts to its original position, the air flows back into the piston rod supply chamber port where it builds up the pressure and moves the piston back. And then they're saying the air escapes the piston chamber via the piston chamber port, right? So now moving on, right? So now we have a what we call a 5-way valve as well. So a 5-way valve. So now they're saying how so now and 5-way valve, when it's not actuated, it operates in the following process. So when the actuated valve is not actuated, the spring holds the piston valve in its initial position, right? So the piston rod of a connected double axis cylinder is pressurized and the piston rod retracts, right? So now when is 5-way valve actuated, right, the control piston is pushed against the valve spring return, right? In this state, the supply port is connected to the side of the cylinder via the valve, right? So while the piston rod side is exhausted via the valve, so the pressure builds up on the piston side, which causes the piston to advance. As soon as the piston reaches the advanced end position, the maximum pressure builds up on the piston side of the cylinder. All right. So now, as you can see, so now this type of 5-way valve that we're talking about, it has a spring return, which means it's spring loaded, right? So now, so it's similar to how a single acting cylinder is, in a sense that it's spring loaded. Right? So it will always retract back to its original position, right? So now moving on to the problem, right? So now they are saying on a loading station, right? The packages are separated and sorted out onto the transport containers by hand. When the containers are full, they are shipped out and replaced by new empty containers. During the changeover, the flow of material needs to be paused though the conveyor belt needs to be kept running, right? So the packages are stopped from moving by a mechanical block or a locking blade. So they're saying this needs to be opened from the loading station, right? So now the process, they're saying when the selector switch is pressed, so now we already know that we're supposed to use a selector switch, right? So we can make sure that the piston is fully advanced up until a point where you choose to release it. So they're saying when the selector switch is pressed, the piston rod on its advances to push the locking blades into the flow of material, right? And they're saying the piston rod remains in a position when the selector switch is released. So they're saying the piston rod remains in its position when the selector switch is released, so that the flow of materials cannot continue. All right. And then when the selector switch is released, the piston rod retracts to the end position, allowing the flow of materials to continue. And then they're saying the piston rod remains retracted up until when the selector switch is actuated again. So they are saying since the parameters here, they're saying since the work needs to be carried out on the forward and on the return strokes, you'll need to use a double acting cylinder, right? So now coming to exercise, right? So now since the main parameter of our exercise, we are told that we always have to use a double acting cylinder, right? So now if we get our double acting cylinder, so now this is a sort of like we had a dilemma now, because up until this point we've been using the 32-way valve, but now if you look at the 32-way valve, you can see that it's not compatible to the double acting cylinder, because it only has one hole which can supply one side of the piston, and then the other side will not have supply of air, or it will not be able to take back the air into the system, right? So now we have to introduce a new type of, or a new kind of push button that is compatible with a selector switch, right? So now that push button, it's called, so now with the contact of this size, we're gonna introduce a 5-way valve that has a selector switch, right? Because the parameters of the size that they told us that we have to use a selector switch. So now we have to use a valve compatible with the double acting cylinder that has a selector switch, right? So now we connect this. So now our 4 should go into the supply position, right? So egg moves through, and then our 2 goes into the exhaust port, right, or the exhaust hole, right? So now I remove this, right, and then I connect my air service unit to here, right? So now I press play. So now you can see the cylinder advances, right? And then, so now when it advances in the context of this exercise, right, the 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 piston rod is blocking the flow of materials now, right? So now the flow of materials cannot continue because the cylinder is at an advanced position up until a point where I release it, right? Then it retracts back, right? Okay, so now moving on to exercise number 5, right? Moving on to exercise number 5. So in exercise number 5, we are stopping milk bottles, right, using a pneumatic system, right? So here, the aims of this exercise is for you to be familiar with the setup and function, or be able to explain indirect actuation, right? And then you should also be familiar with the pneumatically activated 5-way valve, right? And then you should also be familiar with the difference between a signaling element and a control element, right? So now, moving on to the description of our problem, right? So now, sorry about that. So now you should be familiar. So now in this exercise, you're going to be familiar with the functioning of a pneumatically activated 5-way valve, and also be able to tell the difference between a signaling element and a control element, right? So now the so now a description of the process. They're saying a A bottling system is used to fill. The bottling system is used to fill the bottles with milk, right? The bottles are fed in and stopped under the bottling machine by a conveyor belt, right? So I think this task is performed with the aid of a pneumatic cylinder. A test setup of the stopping system will be used to check the position accuracy of the stopping process, right? So they're saying the stopping process needs to be started from the system's control console, right? So now we're gonna move on to the description of the process, right? So now they're saying when the selector switch when a selector switch is pressed, right, the piston rod advances and then pushes the locking blade into the flow of material, stopping the big bolts in place, right? So now you already know that we're supposed to use a selector switch, right? So and then they are saying when the selector switch is released, right, the piston rod moves to the retracted position, allowing the flow of materials to continue. And they're saying the piston rod, the piston rod should remain retracted up until the selector switch is released again. So now the parameters of this exercise, they're saying it should be stoppable to stop the flow of materials from a central control console, right? And then they're saying since the control console can be used to access the compressed air, a pneumatic solution is required, right? And then the last statement saying the control valves for the cylinder should be actuated pneumatically, right? So this statement particularly, so let me just highlight it. It's very significant in determining what. So now they're saying the control valve of the cylinder should be activated pneumatically, right? So which means now we can directly use a push button directly connected to our cylinder, because our cylinder now should be actuated pneumatically, right? Which means there's supposed to be a component that's going to allow air into our cylinder, right? And then we'll be using the push button as a way to signal to that intermediary component that for it to open up so as to allow air into the double acting cylinder, right? So we can't directly connect the push button directly to the double acting cylinder, right? So this process is known as indirect actuation, right? So we're not using a push button to directly actuate the cylinder. Instead, we're using the push button now as a signaling element, right? Or a signaling component that's going to tell the intermediary component, which is going to serve as our central control console to allow air into the double acting cylinder, right? So now going back here, right? So now, as I said in the previous exercise, a double acting cylinder is compatible with 512, right? As I mentioned before. So like now, every time, so now you should know that a double acting cylinder is not compatible to be directly connected to a 3-way valve, right? So now, for us to determine that intermediary component, it needs to be a 5-way, right? And then since now we're trying to actuate our cylinder indirectly, in a sense, right? We can't connect the push button directly to our double acting cylinder, because according to the parameters of the size there, what's allowing air into the cylinder should be actuated pneumatically, right? So you need to find a pneumatic component that can supply air into the double acting cylinder. So if now we go here, right, we're gonna use what we call a pneumatically actuated 5-way valve, right? So now we don't need this because we're not gonna be because we're not gonna be actuating our double axis cylinder using a selector switch that is directly connected to the actuator or to the cylinder. We need to actuate our cylinder using it should be pneumatically actuated, so we're gonna use this 5-way valve. So now the connection here is the same, right? And then now we can also directly connect this to our compressor, right? Because if you connect it to our compressor directly, now it will be sort of like actuated directly, right? So now we need to connect also a push button, right? That's gonna serve as our signaling element to control the 5-way, right? So in this case, since the process or the description of the process was saying that the process uses a selector switch, right? So we'll be using a selector switch. So we'll be particularly using a 3-way selector switch, right? So we connect our 3-way selector switch to here, right? And then we also now we connect this to our service unit, right? So now if we simulate this, right, we can see that there's an open connection here that we need to. So this open connection you can usually just fill in with the compressor. So you're gonna get a compressor, right? So now we are returning the. So now this is the return part of the air when coming out from the exhaust hole of the piston. So now we are saying that when the piston retracting or racing air back system wanted to go back to the compressor, right, so it can be reused again, right? So now we simulate. So now you can see when we press this, that's when now our pneumatically actuated 5-way allows air into the double axis cylinder, allowing it to advance, and then when we release it, it goes back, right? So that's our exercise number 5, right? So now moving on to exercise number 6. So in exercise number 6, we are opening and closing a supply pipe, right? So here the training aims of this exercise is for us to be okay. So before we move on, right? So now this concept, as I explained, it's the process on the previous exercise is called indirect actuation. So you should be familiar with that process and be able to differentiate between direct actuation and indirect actuation, right? I hope I explained it properly, right? Or now you can understand, or you can now contrast the difference between the two, right? So now, exercise number 6. So I think this is a mistake. So we're just gonna move on from it. So let me just address that this time. So start. So now, in this exercise, you should be familiar with the, you should be able to measure the pressure in pneumatic control systems, right? And then you should also be able to be familiar with the function and setup of a one-way flow control valve, right? And then the other function of this exercise is that you should be able to distinguish between flow control methods and use them in accordance to specification, right? So now our one-way flow. So our one-way flow, it's usually a one-way for the function of a one-way flow valve. It's in this manner, right? So now the airflow control in so it helps control the flow of air in one direction, right? So now the check valve, they're saying the check valve shuts off the air to flow in one direction so that the air can only flow via the indicated cross section, right, as you can see here. So air flows freely in the reverse direction through the open check valve, right? So these valves are primarily used to regulate the speed of pneumatic cylinders, right? So this is very important. So now, let's say, for example, you want to control the speed at which a cylinder advances, right? And then you also want to control the speed at which a cylinder retracts, right? Right. So as I was saying, like the one-way flow valve, it helps us to be able to regulate the speed at which our piston advances and retracts, right? So that's basically like its most like basic function, right? So moving on, right, to the problem. So they're saying find a way to open and close a locking plate. Saying use a selector switch for the actuation, and then use a double acting cylinder as a drive, right? So now, saying when the selector switch is actuated, the piston rod on the cylinder advances to allow the air to flow through, right? And then I say when the selector switch is reset, the piston rod returns to its normal position, locking the plates, right? So the parameters, they're saying the locking plate must open slowly to ensure that the pipe is not subjected to excessive loads, and they're saying the speed of the stroke should be adjustable, right? So it's saying each forward and return to straight to take 1 second, right? So now going back to our circuit, right? So as I said before earlier, I said for us to be able to retract the speed at which our cylinder advances and retracts, we need the help of a one-way flow valve, right? So now we'll be using one-way flow valve, right? So now the other steps is determining where should we put our one-way flow valve. So I'm going to delete this, since they said so like now, the reason why I deleted this, they didn't say our circuit should be pneumatically actuated, right? So we do not need it at this point, right? And then we also remove this. Right. And then going back to, again, our exercise, right? So they said cylinder must open and close slowly, right? So we are regulating, so now in this case, we are regulating both sides. Like when the cylinder advancing and when the cylinder is retracting. So now it means we have to put the one-way valve on two sides, right? So now put it on the exhaust side and as well as the supply side, right? And then now, as I said, we can't use a double acting cylinder with a 5-2-way. So now we'll be enlisting the help of and again, since they said the switch that we're supposed to use has to be a selector, so we don't have to press and hold, right? We use a select a 5-way selector switch, right? And then now, so now another thing, right? So now you can see from here it's still advancing at high speed. So now to regulate the speed, we double click, and right, and now to help you can say display the opening level, right? And let's say we put it at 2%, for example. Put the opening level at 2% and then we also put this one at 2%, right? Because they said they should both advance and retract at a slow pace, right? We should take at least 1 second, right? So now you can see it's advancing slowly and it's retracting slowly, right? So now this is how so now you can see how a one-way directional flow valve works, right? Okay, so now moving on to exercise number 7. So in exercise number 7, we are shutting off using a quick power lockout, right? So these are the training exercise. These are the training ends of the exercise. We should be able to set the advancing. You should be able to set the advancing and retracting speeds of cylinders, right? And then you should also be able to distinguish between flow control methods and use them accordingly, right? So now, the description of the problem is saying use a bottling system used to fill bottles with milk. The pipes through which the milk flows are open and closed using a knife gate valve, right? In order to prevent the milk from spilling over at the start of the filling process, the opening process needs to be executed slowly. So now they're saying the opening process needs to be executed, so which means the cylinder needs to advance slowly. They didn't mention anything about it being retracted. But now to us to get more detail, we have to go to read on how the process works through the description of the process. So now they're saying the cheese is inserted by hand, right? And when a push button actuator is pressed, right? So they're saying a push button actuator, right, is pressed, right? So a push button, they didn't say a selector switch, they said a push button, right? The cylinder advances, right, and then presses the cheese onto the mold, right? And then the push button actuator, okay, no, I think this is a wrong process. Let me try and see if I can also fix this. So okay. So So now they didn't give any parameters for this exercise. I apologize about that. So now they're saying when the selector switch is actuated, when the selector switch is actuated, a knife gate is open slowly, which means the cylinder advances slowly, right? And then when the selector switch, when the selector switch is reset, right, the knife gate allows allows the allows the knife gate to close in quickly, right? So now the main question of this exercise is for you to decide on whether the supply airflow control or the exhaust flow control is like which side of the cylinder you can use to solve this problem, right? So which means we need to decide on whether you need to limit the airflow on the supply side or on the exhaust side, right? So now, since they are saying the air, it goes in slowly, right, but it comes in quickly, all right? So now it means we need to slow down the air when the cylinder is advancing, which means we need to slow it down on the supply side, right? So which means we can either now put this at 100, right? And then now you can see cylinder advances slowly, but it returns quickly. Advance slow, returns quick. We can either do this. This is the first answer to this question, right? We can either do this, or we can remove the one-way flow this side, right, and just connect it direct to the exhaust side, because you don't need to regulate speed when it's exhausting, right? So still same output. So there's one of two ways in which you can answer this question, right? So now moving on to exercise number 9, which is going to be our last exercise, right? So we're going to skip number 8 since it's a homework, right? I'll do it in the next video. So now I want you to go try exercise 8 and 10 by yourselves, right? So now I'm just going to do 9 and then you're going to conclude. So now exercise 9, we're expanding a control system to enable the pressing of a cheese, right? So now we're expanding our circuit from exercise 1, right? So now the training aims of exercise is for you to be able to expand an existing control system, right? And then be able to analyze a proposed solution, right? And be able to implement an OR operation, right? So now, before we move on any further, right, I want us to redraw the circuit from exercise number 1, right? So now this was our circuit from exercise 1, right? So now so like the purpose of this exercise for us to be able to expand on this exercise to make its design more complex and also more to able to expand it so that it can achieve a higher function, right? So now we'll be expanding on this design, right, through implementing an OR solution, right? So now before we go to that, we have to talk about an OR valve, right? So an OR valve, right, it works in a manner such that it can allow two inputs and one output, right? So now it can allow two inputs due to the fact that, let's say we have to fulfill two conditions before we allow it into the actuator or the cylinder, right? In a context such that, let's say for the cylinder to advance, we need to we need to press two push but like either one push button or the other, right? So let's say the push buttons are in two locations, right? And they can be activated by, let's say, in a manufacturing setup, let's say at the control room, they have that push button, right? And then the operator also has that push button on the assembly line, right? So now they are saying let's say to activate that operation, right? You need to it can be implemented through the use of an or condition. So like you need to create an or condition so that like either the person who's in a control room or the operator on the assembly line can initiate the process, right? So now they're saying so now for you to make this connection for you to initiate the process, either of these pushes can be pressed, which can cause the sender to advance, right? So this is how the functioning of a OR valve works, right? So now, but like, I want us to focus on the highlighted system, which is saying if a cylinder or control element needs to be actuated from two or more locations, one or more OR valves must be used, right? If there are signals at both inputs, the signal that arrives first or has the higher pressure will reach the output, right? Which means like, yeah. So I think it's a direct explanation, right? And then I also want us to, at this point, I want us to talk about an AND valve, right? So an AND valve works differently for an OR valve in a context that an AND valve, right? It requires, since like I just told that like an OR valve, it requires one of the inputs to be true for it to send to send or for it to allow air to move into the cylinder. An AND valve, it needs both of them. Both of the switches, they both need to be on for air to move to the cylinder, right? So they're saying the airflow can be present when both the input signals are present, right? And saying if only an input in one, if there's only an input at one of the 2 points, the flow will be shut off to the differential forces at the piston spool, right? If there's a delay between the signals, but they both have the same inlet, right? Inlet pressure, the last signal that arrives reaches the output, right? Which means that you don't have to press them at exactly the same time, but you can press one and then you can press the other one, which means as soon as the other one, the one you press last is pressed, air will go through because the signal of the first input that you've been pressing, it will move to the output, right? And then if there's a difference in pressure between the two signals, the signal of the higher pressure closes while the valve of the lower pressure reaches the output, right? And then they're saying the AND valve is mainly used for locking control systems, monitoring function, and logic functions, right? Okay, so moving on to the process. So they're saying in cheese manufacturing, pneumatic cylinders are used to press the cheese into molds, right? The pressing procedure is operated using two push button actuators. Now you're seeing you need to implement a system that allows the operation to be carried out using two push buttons so that the pressing procedure can be operated from either the loading side or the unloading side, right? So here they're saying different solutions exist, but a solution. Okay, so now we'll move on to so like they're saying now the cheese is inserted by hand, right? And then a push button actuator on either side of the loading is pressed and the piston rod advances, right? So now from here you can tell that the piston rod, its initial position is not supposed to advance, it's supposed to be retracted. So now you know that I'll be using a normally closed 3-way valve, right? And then it presses the lead onto the device, right? And then they're saying when the push button actuator is held down up until the procedure is complete. So this statement tells us we're not using a side actuator, instead we're using a normal push button, right? And they're saying when the push button actuator is released, the piston rod retracts, allowing access to the device for the cheese to be removed, right? So they're saying the cylinder must be pneumatically controlled using a second manually operated valve, right? And then they're saying it should be possible to operate the process on either two sides of the valve. So this parameter will be fulfilled using the two push pins that we're supposed to use, right? And then, okay. And then now, since, as I said, we're using these two push buttons extending from this control system so that we're able to control the system from either the loading or the unloading side, we need two push buttons, right? So now, we remove this link. So now to make sure, or to make sure that we can control from both the loading or unloading side, so we need to push one. This is for the loading side, and this one is for the unloading side, right? And we need to create a condition that allows us to control like from either of the directions. So now we use what we call an OR gate, right? So an OR gate, it creates, so it allows us to either advance the cylinder on either this pattern or this pattern, right? So both of the push buttons don't need to be pressed or activated for the cylinder to advance. Only one of them, since it's an OR condition, so you can control the system from the loading or unloading side. So connect from here to here, right? And then straight into the piston, right? And then now, okay, so now you can see I'm getting an error here. So I left an exposed hole here. So now, and again, this needs a supply of air. So now for us, we need to have a compressor and an air service module, right? Here connected to here. Okay, that's fine. And then we connect it to here, right? So now we have a supply of here on both of the lot. So now if we simulate this, the reason why I did this is to ensure that like all, so can I say, like clean air goes into our piston, right? So now if you look at this, so I can either advance my cylinder from this push button, which is from the loading side, or I can use the one on the unloading side, right? So now that's exercise 9. So before I close off, like I also want to introduce another push button, right, that's related to the OR gate. So this is an AND gate, right? So an AND gate, it, in such a sense, the difference between an AND and OR gate. So in an OR gate, we only need one of the push buttons to allow air into the circuit for the cylinder to advance. But using an AND gate, right, we need both of the push buttons to be advanced for air to go into the cylinder, right? So now I want you to try implement this exercise, but now I want you to use an AND gate, and also instead of using normal push button, I want you to use the selector switch to try and fulfill the AND condition that's gonna cause this cylinder to advance, right? So I want you to use selector switches and this AND gate. So this is an AND gate. So that will be all for this exercise, and we'll continue the next exercises on the next session. So in the next session, I'll start with exercise 9, right? And then from exercise 9, we'll go through 10, 11, and 12, right? So thank you for your time, ladies and gentlemen.